All right, just wanted to do a couple extra examples for Chapter 8. So this first one, it says you are interested in finding a 90% confidence interval for the mean number of visits for physical therapy patients. The data below show the number of visits for 14 randomly selected physical therapy patients. Round answers to 3 decimal places where possible. Okay, so part A now asks us, to compute this confidence interval, what distribution will we use? All right, so what we're looking for, remember, when we use the normal z interval, which is the standard normal, we need to know sigma. So for the z interval, we need to know sigma. I always think of like z and sigma, even though sigma doesn't start with a z, sigma, it sounds like it. Okay, nowhere in here does it tell me the remember, sigma is the population standard deviation, not just population, it's the population standard deviation, PSD, standard deviation, okay? We don't know that. We have a list of data here. We can calculate the sample mean and the sample standard deviation, but we cannot calculate the population standard deviation when we don't know population data. Okay, so since we don't know that, if we don't know sigma, we cannot use the z interval. We have to use the t interval. So think of if you're able to calculate the sample standard deviation s, as long as you have a list of sample data, you can always calculate s. And S and T are right beside each other now. So this is going to be a T interval. Okay. Even if it tells us the underlying distribution is normal, we're still going to use the T interval if we only have a sample list of data. Okay. So now in part B here it says, with 90% confidence, the population mean number of visits per physical therapy patients is between blank and blank. So this is actually giving us the interpretation. So what I want to remind you guys is if I give you a quiz or actually on the test or some of these weekly worksheets, you're going to have to write out this interpretation. So usually what I say is, write down the interval. What you're estimating is mu. Okay? So we're going to write down the interval that the calculator gives us, and then we can fill those numbers into our interpretation here. Okay, so in this problem, because it gives us a list of data, we want to go to Stat and then Edit. Okay, and I actually did. You can go up here and hit Clear and then Enter, but I actually have input the data into L1 here. Okay, so go ahead and do that. Type them in. 6, Enter. 22, enter, 15, enter, etc. Okay, can you guys do that? I'll wait a second. Or hit pause. Okay, to get the confidence interval then, just like we did when we had the data, we hit Stat, we go over to Test, and because in part A we said we're going to use a T interval, remember these first couple ones I said earlier, I think, any of the ones that have test on them, we're not going to use until chapter 9. We want to go all the way down to the intervals. So we have Z interval, T interval, etc. So we are going to use the T interval. Eventually we will use these 2 sample ones next week, but this week we're just doing the 1 sample. So we're going to pick T interval, hit enter. Okay, now when we did the earlier examples, we used stats. Remember, and I'll show you, we put in the sample mean and sample standard deviation, but in this problem we have the data, and it's important for you to select data here, because if you don't, and you put in the standard deviation and the mean, you're going to have rounding errors if you round it. Okay, so this way you don't have to calculate the mean and standard deviation separately, you just put in the data. I actually have the data in L1 here, so you can hit enter or down. We leave the frequency as 1. Some of your calculators may have that as blank, and that's okay to leave that blank. Now, our confidence level for this example was 90%, so I'm going to change this to 0.90 for the confidence interval. Make sense? So we hit calculator, and it's going to give you the 2 numbers in an open interval notation. It has these parentheses. Sometimes in MyOpenMath, it'll ask for it in this notation as well. This one does not. It actually puts it in the interpretation. Okay? Okay, so the calculator gave us 11.997 and 18.717. So with 90% confidence, the population mean number of visits per physical therapy patients is between 11.997 and 18.717 visits. Okay, this is the interpretation. So even though the MyOpenMath is giving that, you are going to have to be used to writing that, okay? So I just wanted to show you that. So if MyOpenMath is asking this type of question, if many groups of 14 randomly selected physical therapy patients are studied, then a different confidence interval would be produced for each group. About, and this is our confidence, 90% of these confidence intervals will contain the true population mean number of visits per patient, and about 10% would not. Does that make sense? All right, let's look at another example here. Just a different way they ask you to show the confidence interval. Again, on a test, I'm going to ask you to show it as an interval with mu in the middle, and then also writing the interpretation. Those are the two main things I'll ask you on a test. Okay, so here it says the body temperatures in degrees Fahrenheit of a sample of adults in one small town are given. Assume body temperature of adults are normally distributed. Based on this data, find the 90% confidence interval of the mean body temperatures of adults in the town. Enter your answers as an open interval. And that's what the calculator gives it to us, like an open interval. Assume the data is from normally distributed population. Okay, the normally distributed population thing is just telling us it's okay to use the t-interval. We do not, because the t-interval has an assumption that the underlying distribution is mound-shaped or symmetrical. So we don't know sigma. Sigma is unknown. So we're going to go ahead and use the t-interval here. And we're going to go ahead and put that data into the calculator, hit stat, and then for edit, we're just going to hit enter. Now, I have gone ahead and put this data into L2. You can either put it in L1 or L2. It's up to you. So go ahead and type that in now. You can hit pause on your thing, hit second quit. When you're ready to go on, we're going to go stat over to test again, just like we did before. Again, this one, as we said, is going to be a t-interval again, and it gives you the data. Okay, so remember the difference between the z-interval and t-interval. The z-interval is when we know sigma, t-interval is when we don't. So we don't know this, we just have a list of data. We're going to put the t-interval. Again, we can either pick stats or data here. I'm going to hit data. Enter. This time I actually put my data in L2, so I'm going to say second number 2 to change that to L2. I'm going to leave my frequency as 1. Again, this is a 90% confidence interval, so 0.90. It just changes it to 0.9, which is totally fine. Hit calculate, and I have my confidence interval. All right, so we got 97.629 and 98.643. Okay, that's writing this as an open interval. So if as I want you to show it, you would show it as interval with mu in the middle here. Okay, that's just showing that mu falls between these two numbers. So the interpretation would be with 95% or with 90% confidence, or oftentimes I say we are 90% confident that and then I go back to the problem. It says find the 90% confidence interval. And this is what I'm looking for in my interpretation. We're 90% confident that the mean body temperature of adults in the town. Now, I think they actually even say the population mean, which is fine, is between 97.629 and 98.643. And you have to put the units here, degrees Fahrenheit. Make sense? Okay, one last example here, just to practice using the confidence interval, or I'm sorry, using the finding, not the confidence interval. This is where we want to obtain a sample. You want to obtain a sample to estimate how much parents spend on their kids' birthday parties. Based on previous studies, you believe the population standard deviation is approximately $55. There's some extra there. You would like to be 99% confident that your estimate is within. Okay, that word within is going to tell us our error bound, $5. As soon as you see within, you know that's your error, margin of error. Spending on the birthday parties. How many parents do you have to sample? So we're going to use our formula that I showed you in the last video, Z critical times sigma over the margin of error squared. Okay, so we have to look up that Z critical. So if you use the tables that I gave you, or that I have posted, I should have them posted that we used in our test. There's a little table at the bottom. I don't have this pulled up right now. And you can see it shows the confidence interval for critical values. They'll say level of confidence. I go down to 99%. It's the very last one, is 2.58. Okay, so we have n equals 2.58 times sigma, which is this 55, over the margin of error of 5 and square it. Okay, so if we put that in our calculator, I'm just going to go ahead and do that. You guys, I'm not going to show you separately on the calculator. 2.58 times 55 divided by 5 and squared. I get 805.4244. Remember these, even if this is below 5, we're always going to round up. So our sample size would be 806. Make sense?